All right. Welcome, everyone, to another episode of AWS's Howdy Partner. I'm A.M. Grabelny, joined with my, best friend? Would you call us best friends, Mo? What do you think?
Yeah, definitely.
Okay. One of my best friends, Mo, and another one of my best friends, Chase. Sorry to like really just,
Howdy, partner.
Uh-oh.
Wow, Chase brought it. I don't know if you can beat this. And Farah, of course, also we're best friends. I've got a lot of best friends. I can't help it. Very friendly person. I'm a Texan, after all. We have to be friendly, even when we don't want to be. I'm just kidding. I love all of you. We're all best friends. I cannot believe, Chase, you brought a
10-gallon hat?
It's pretty
yeah.
amazing.
I think yours is only like a 1-gallon hat, honestly. I mean,
I don't know if I could even fit a gallon of it. Vance is not built for water holding, but your hat definitely. That's, wow. I'm speechless. I don't even know what to say now. I was going to intro the show and like talk about what we're here to do and who we are.
I stunned you.
You out howdied me. I think you're the host of the show now. It's your show. I have to give it to you. Right?
All right.
Is that the rule,
then.
though?
I think so. Yeah.
Okay. Well.
And with that.
Yeah. Tell us what Howdy Partner is, Chase. I guess since you're the host.
Oh, Howdy Partner. Well, it is the root-tootin'est place to come and learn about all of your serverless friends and what they're doing to make your life on AWS easier and happier.
This is the rootinest, tootinest, wildest show in the wilderness. Howdy Partner. We're apparently interviewing the most Texan Oregonian of all time. Chase, the CTO and co-founder of Stackery. I'm joined here with Mo, one of my co-hosts that you'll see throughout the series. Mo, you want to tell us a little bit about yourself?
About me? I'm a Partner Solutions Architect at AWS. I work with AM. Big serverless fan. Super glad to be here with Chase, the rootinest, tootinest cowboy of them all.
Yes, and I'm AM. I'm also a Partner Solution Architect here at AWS. And we are spending this show teaching you all about AWS partners, right? People who are a part of the Amazon Partners Network, which means that, we work well together. We partner together. Oftentimes a lot of the companies that you'll see come on here will have a direct integration, or they'll build a tool that makes using some aspect of AWS even easier or better in some cases. And that's exactly the case that we have here with Stackery and with Chase. So Chase, tell us about yourself and just give us a high level about Stackery. And then I think Mo has got some content that he has prepared to give us an intro to serverless and AWS and Stackery. Sound good?
Yeah. That sounds great. So I'm Chase Douglas. I'm the CTO and co-founder at Stackery. And our goal is to help our customers and our users design, develop, and deliver serverless applications securely. We're essentially a serverless platform for AWS. And so we help people through the entire software development lifecycle, making sure that they are successful building out modern applications. So I'm looking forward to getting a chance to show everyone about serverless, best practices on AWS, and how we help them with that.
Cool. And we'll be doing this show for the remainder of May up until June, every Monday, every Wednesday at exactly this time, 2 p.m. Pacific. And we'll be featuring all kinds of different AWS partners. Definitely not just only serverless, even though Mo and I are a little partial towards serverless, I guess you'd say. Yeah, Yeah. We actually have an episode tomorrow at the same time and an episode Wednesday of this week at the same time. So be sure to join us for those. We've got an upcoming partner show, a special non-Howdy partner related partner show coming up on Wednesday as well. I'm not sure on the time on that. Maybe Paul, you can drop that in chat. But yeah, we be sure to check that out too if you're a big fan of AWS partners, which Mo and I, we definitely are, right?
Certainly are.
Cool. So Mo, you're gonna oh, they're asking for a yeehaw from someone.
Yeah.
Okay, we don't even have to wait for it. I love it. I love it. That's amazing.
There we go.
Yeah, I think you win Howdiest partner of them all so far, Chase. You're really raising the bar on this. It's amazing. I'm very pleased.
I gotta show up the Texan.
You do. Yeah. Mo and I both are kind of losing our Texas cards here.
A little bit.
So what are you going to talk to us about, Mo? You're gonna what? Give us kind of an intro to what serverless is. Let's say, I don't know, just hypothetically, I've never heard of serverless. I don't know what it is. I've never touched it. Right? Are you going to teach me?
I'm going to try. I think you should start by saying that if you're technical and you're in the audience, obviously developer and architect, please follow along and participate. We'll have GitHub repos. Chase is going to be doing some really cool demos, so follow along and participate. And if you're not technical, feel free to follow along as well. That way you can learn how Stackery can I think radically change how your engineering colleagues ship serverless applications. But to talk about serverless, I thought we should start with kind of defining what serverless is. Obviously, serverless has gained a lot of attention, developer love over the past few years, and I thought I should set the stage with what exactly serverless is and how to develop serverless applications, because it's different. So serverless to me, and AM, you and I have talked about this a bit, but to me, serverless is obviously applications that scales with usage, high availability is built in. You're not paying for idle time. So unlike an EC2, you're just not paying if a service is not being invoked. There are no servers to provision or to manage, no software to install, all that good stuff. But is serverless different to you, AM?
Yeah, I think I use those qualifiers to figure out if a service kind of meets a serverless use case, right? Or if it meets what you'd call something serverless. I don't know if that's what serverless means to me. I think serverless is a larger term for me. And that doesn't really apply necessarily to specific services or how you build something. I think serverless for me, one of the first things that it did, I'm not an infrastructure like heavy person, right? I did not come from an ops background. I came from mostly a coding background, right? Like I was working on features and products and writing code. And deploying out an application when I first got started writing code was really, really complicated, and I couldn't figure it out necessarily, right? But first time I was introduced to Lambda, it really kind of democratized some of software development to me, to where like I didn't have to rely on other people to get my code to run somewhere. So to me, that's kind of what caught my attention with this whole serverless movement and things like that, and got me really interested in it. And then, individual services, how they are, operated and build and all these things are, more important as I get deeper into this world, I think. Is that what you're asking?
Yeah. I think that's what I'm asking. Chase, okay. Do you have anything to add?
Yeah, I believe in that democratization point. I know that there's a lot of aspects of software development that as an engineer working on a product or a project, you're probably never going to touch all of them. So everyone ends up specializing in building skills and experience around different aspects. But this really gives people the ability who are developers who understand how to build web pages, how to build APIs, but maybe don't know how to scale that to the size of the types of application infrastructures that AWS is known for being able to serve and to scale to. Serverless really gives those developers the tools to just operate at the foundational building block level. So for example, you may not know how to scale up a fleet of load balancers to serve in front of your API server, but you can take API Gateway off the shelf and know that you've got a completely horizontally scalable load balancing infrastructure piece that also has routing and authorization and other advanced mechanisms built in, so you can get back to just focusing on the business logic that makes your application and your product special.
That's it. I think that's perfect. So I think that's a great segue into talking about developing serverless applications, because it's a bit different than traditional app development, and that like you all said, serverless itself is different in terms of building, developing, and testing applications. We were talking earlier about setting up LAMP stacks and how you can just set up a LAMP stack on your laptop, kind of program away. But with serverless, you have all these architectural components, essentially building blocks, like you said, Chase. So, like for example, compute, Lambda or Fargate, storage, S3, databases, DynamoDB or Aurora Serverless. Maybe all of them integrated together with SQS, SNS, EventBridge. But what this does, I think, is when it comes to developing, you can't just emulate all of these services that run on the cloud on your laptop, right? So like maybe you can run DynamoDB locally. And AM, if you'll help me out here, I'll show my screen.
Yeah, let's get your screen up. We're so used to localhost being there, right? And when it's not, it's a challenge to first learn, what that means.
Right.
All right. So you should be, there you are.
So just to illustrate, I can run DynamoDB locally. This is a Docker container essentially that localizes DynamoDB for you. Pull that over to the side. Make this a bit bigger. And just to prove it, I can maybe create a table. Create the Howdy table.
I think automatically Chase owns that table now too. Howdy table. I mean, it's his now. Stop naming stuff Howdy. He just.
I think if you look deep inside the IAM documentation, that it is part of the spec there.
If you name something Howdy, it becomes.
And just to prove that the Howdy table exists, I'll just call list tables. Should see that right away. But I think the problem here, and I'll stop sharing my screen, just trying to illustrate that really quickly, is that you can't do this for all of the services that you have running, right? Especially if you have a really cool pattern, like an SNS to Lambda, super big fan out. I can't do that on the 2 gigs of RAM that I have left after running Chime and Outlook on my computer. And so on top of that, I think there's this element of with microservice development and serverless app development, there's a 2-piece team concept. So there's no way me and the homies can work together on this. And then on top of that, sometimes you're not developing a brand new serverless application, but you're refactoring an existing application to work serverlessly. And so you find yourself in a position where you need to use a framework. You need a framework. And
it's interesting that you say maybe you're refactoring an application.
Maybe Chase has something up his sleeve for later today. But yeah, frameworks help with IAM permissions, maybe IAM permissions to invoke Lambda. They help with zipping up your code and your dependencies, dealing with failed invocations and dead letter queues. And hopefully your frameworks don't force you to deal with endless YAML because of CloudFormation. I think all in all to say that you can't really recognize the benefits of serverless if you end up having to deal with the same infrastructure that is supposed to be abstracted away. Frameworks are supposed to ease that burden, and that's why Chase is here. He's going to tell us all about Stackery and how designing, developing, and deploying serverless applications should be. Chase.
Awesome.
Oh, is Chase present? Oh, no, he's there.
I hope I'm still here.
Oh, yeah.
I'm still good? Awesome.
You're great.
There we go.
You're not just good, Chase. You're great.
The funds of streaming from our houses during all of this. So.
Totally.
Yep. All right. So, yeah, this is my bread and butter. This is what I love. I love helping people build modern applications on the cloud the way that they should be built, which is letting you focus on the things that are important to the product you're building and leaving all of the infrastructure bits to AWS. The stuff that's really hard that is the same across, or should be approximately the same across all the different products out there that anyone might build, being able to scale, being able to store data inside of tables and databases. But that doesn't make your product special. What makes your product special is how you piece those things together with some business logic to solve a problem that hasn't been solved before. And so my goal is to help anyone out there who needs to do that and wants to do it at a cheaper, more scalable way to do that using serverless and modern architecture approaches. So what I'd like to do is maybe start off by talking through what are the aspects that you're going to need as you are building modern applications. So the first thing that you're going to need is a way to design these applications. As we've been talking about serverless applications, we're talking about piecing together lots of different components, what people may have previously called microservices, but in this case, each component is represented and served by a different service for a different use case. So instead of being generic microservices, this is API gateway for running a REST API, let's say. This is DynamoDB for storing data inside of a NoSQL table. SQS for doing a background job queue. So the first step is being able to rapidly design an application. So I'm going to start by showing my screen and take a quick look at the Stackery interface just to kind of acquaint ourselves with what this might mean for designing a stack. So inside of my demo account for Stackery here, I've got a list of many different stacks. I'll hop into one that I love to show off. It's a single page application that is based around the Wild Rides workshop that AWS put together. And we have here an application that has a single page application style front end that's hosted inside of an S3 bucket. And the business logic, when you say sign up, when you ask for, in this case, the business logic is actually requesting rides from a unicorn, the same way you would request cars from Uber or Lyft. So, it's unicorn sharing as a service. And so you could request them through a Lambda function that is accessed through a RESTful API service, which is up here. And that interacts with this DynamoDB table. It also interacts with Secrets Manager to be able to hit an API that actually has the unicorns for us with an API key. So the point of me bringing this up is to show that in the past, you might be used to building monolithic applications where every bit of the functionality is served out of one application repository, instance, process on your machine that then gets hosted inside of a server. Now we break all of those pieces of functionality out that are core infrastructure into separate services. So our REST API component is broken out as part of a API gateway API. The user authentication and sign-up mechanism is controlled via a Cognito user pool. The business logic is in a Lambda function, and so on. So building...
Two things, Chase, two things. One, it's very important that I interrupt you for this. Jeremy Daly says hello.
Hi, Jeremy.
There you go. And number two, I wanted to ask, I feel like something that plays a huge role in serverless development is abstraction. And what it sounds like you're talking through right now are just larger abstractions, right? Like pieces that are put in place to take away the more lower level layers of an application. What do you think abstraction plays into with serverless development, and how does it relate to what you're showing us here?
Yeah, serverless development it's the modern way to build applications. And anytime you hear about new ways of doing things that are better, it's inherently in software engineering world, it's because it's a better abstraction. It makes it easier to do what you're wanting to do, faster to accomplish, more scalable. It's whatever facet it is, it's a better abstraction for best practices that have been developed previously. And so why reinvent the wheel? Why figure out how to build a load balancer or an API gateway? Why do all of that again instead of allowing the experts who are amazing at it, AWS and their army of engineers and solution architects, just amazing people who know how to build all these things at scale? Let them do the heavy lifting of figuring out how to make this scalable and cost effective, while you just focus on the parts that are different for your application. It's all about abstractions.
Cool.
Awesome. So we talked about this design phase. We also talked about how we might have API keys, or maybe even we think about how if I'm going to build this project, I'm probably going to want different environments for production, staging, development environments. And so inside of Stackery, one thing that we provide, and any tools that you're going to consider to use should provide, is an idea of an environment abstraction on top of AWS. AWS does a great job of giving you raw materials inside of regions in your AWS accounts. You can even structure organizations of accounts, but there's still an aspect of being able to define a namespaced region within each account and call that an environment where resources are deployed into, or even parameters or secrets that are used by resources can be referenced from. So I've got a list of environments here that can be hosted in a number of different AWS accounts and regions. I'm going to hop into, let's take a look at our development environment here. And I can see I've got a bunch of deployments in here. I also have some parameters. So for example, we're going to start to play around with an API and seeing how we can refactor it. And this API that we have, it already has a database that we're going to use. I could put information about that existing database inside this parameter storage here. I can likewise do similar things. Let's say I need my database password for that database. I can have that password be put into this one environment's namespace inside of the development account and region. So having this environment abstraction is important for being able to rapidly iterate and collaborate and develop software using best practices that can be deployed and tested on its way through to production.
Yeah, this is like something that's like near and dear to, I think, anyone who's ever built a serverless app. Is this is often the first question you get, because typically you're used to just injecting environment variables into a server, or being able to pull from some distributed configuration layer or something, right? And often right. That's it's funny. Every time I get into a conversation with somebody who does serverless development, it's always like, how do I take this long-standing pattern and make it serverless, right? Like that's how I generally, a lot of the conversations I have are framed. So yeah, I think this is a good point to call out, Chase. This is like the distributed configuration tooling that you would use in a containers workflow or a traditional just like server-based workflow, right? Like this is where you can update in one source of truth all of the things that you need to connect up to the other pieces
exactly.
of the microservice architecture you're deploying or your databases. Yeah. Okay, cool.
So these were the foundations of concepts that I wanted to make sure we got across before we started to dive into a live demo today. So first of all, before we dive into the demo, I was hoping whoever has the ability to control what URLs get put into the comment section of the Twitch stream, I'd love to be able to show people the link to how they can sign up for Stackery in case they want to play around as we're demoing. There's also a link to this Git repository that we're going to follow along with as we are working today. I'll describe a little bit about what we're going to build in a minute. And I think also there was a, I think that's exactly what we're looking for. So how about we start talking about what we're going to focus on today? I'm guessing that out there, for everyone who's listening in, you have some great ideas for new projects you'd want to build, but you probably also have a bunch of applications that you currently manage and that you have to continue to maintain, even though they were built in a pre-serverless era. And when you're trying to maintain existing infrastructure, it can be hard when that infrastructure is very valuable, that application is very valuable, and especially if it starts to be used a lot more, you have to scale it, but maybe it's not written in a way that's as scalable. Or maybe as it scales, it becomes more error prone or extremely costly. This is a very typical thing that can happen with applications that you start off building just on your laptop and you host it and it had little traction at first, but then it grew over time to serve a valuable need for people. And now you have to figure out how does this continue to scale? And so many tutorials, so many examples for serverless are focused on how do you build a new application. They're also focused on how do you build things with Node.js and Python. Those are two great languages for building serverless applications, but there are lots of languages out there, lots of applications out there that are already written, already hosted, and some of them could get some love in figuring out how they can scale and be maintained better. So I started thinking to myself, boy, what is AM's favorite language to write in? That's where this came from, 100%, I gotta say. AM would always tease me. What's your favorite language, AM?
My favorite language, famously, is whatever language you pay me to write in. That's my favorite language. I don't care. If the check clears, I'll write in that language. Doesn't matter.
Maybe that's the problem. I haven't paid you enough.
That's right.
I guess that's the issue. Yeah. So for having not paid you anything, what does that mean your favorite language is, AM?
So for today's stream, my favorite language is C#.
For today's stream. Oh, come on. You're hiding it just a tad. How many conversations have we had where you have just been going on an ode to .NET?
I think Chase is really about spreading misinformation and lies today for some reason.
Really? Really?
No, look, okay. I do. All right. I will fess up here. I am a large fan of C# and all of its language features. It's a really beautiful language. It takes my favorite thing that C# does and .NET in general. What they do is they go and look at other languages and see like successful things that happen in other languages, and then just add it to C#. It's awesome. Like it's great. It's really, really hard though. I'd say as a C# developer, since it's a strongly typed language, you don't have as much flexibility with types like you do in Python or Node. Working in this really short, kind of concise function world of Lambda. Because you have to ask yourself these questions that other people writing in other languages don't. You have to ask, like, do I make a model for this thing, or like, is there already a JSON converter that will work for the events coming in to trigger my Lambda, or, do I have to write that? Or, what happens to all these, like Chase keeps mentioning frameworks, and, C# developers traditionally or stereotypically rely pretty heavily on Microsoft built frameworks, right? Or really great community things like JSON.NET, which gets pulled in and packaged with the rest of the framework. Actually, that's what seems to happen with a lot of the Microsoft world, is that like you write a really cool library and eventually they just they pay you to write it or something. Like it just gets, like at any framework, it started outside Microsoft, but now it's just a part of .NET. Yeah, like you have a lot of these bigger questions to ask yourself. I think it's also true of Java too, right? Since it's also a similar language to C#, it's got a lot of the same constructs, a lot of the same things. So I'm really excited to see what Chase has done here with .NET as an outsider to this world. I already should I tell on you, Chase? Should I out your pronunciation of the web framework that Microsoft?
Oh, come now.
Should we keep that? Should we keep that between us?
There's going to be plenty of flubs, I'm sure. I will confess. Right. I will confess that while .NET is AM's favorite language, it is not my language that I reach for. And I'm also going to be working on Windows today, which is not my normal environment. You're going to see lots of dumb, stupid errors where I hit the wrong key on my keyboard. So bear with me, but we're nonetheless going to have a lot of fun today showing how we can take a .NET framework application that may have been written to run on a Windows server in a monolithic way. And we're going to write it, refactor it, so that parts of the web API routes can be rewritten using a Lambda serverless approach. So we're going to have a lot of fun with that. I don't know, anything else before we get started, dive in?
No, I think we should welcome the new audience. So for everyone that's joined, we're here with CTO and co-founder of Stackery, Chase. He's going to be teaching us all about how Stackery can help develop, design, and deploy serverless applications in the best possible way. And right now we're about to hop into this demo. So take it away, Chase.
Awesome. So I have this GitHub repository, which was, the link was shared in the comments just a little bit ago. This is a traditional .NET framework app. So what I mean by that, for those who may not be quite as aware of the .NET ecosystem, .NET framework, it represents the original lineage of how you would build, so let's say the runtime for the language of C#, how you build web applications and other types of applications. It's the .NET framework runtime is closed source, and it only runs on Windows. In the past few years, Microsoft has moved to create a new open version of .NET called .NET Core. .NET Core can run on Windows, OS X, Linux, many different platforms, can run in many different environments, including Lambda, and it's the future for all .NET development. But of course, there's many older applications written on .NET Framework today. And so we're going to show today how we can convert parts of an older style .NET framework. Here we have a very simple web API. We'll see the functionality in a minute. That's got a smattering of routes that are run by two different controllers. And we're going to find how we can pick off one of those quick controllers and re-implement just that one controller in a serverless fashion with Lambda. So this is the repo, and I've already cloned that down. And I have got it open here inside of Visual Studio on Windows. Inside of here, we've got a very typical .NET framework layout. We have models. In this application, we have records for books and authors. It's kind of like we're a library. So we have a book model, which can, there we go, which has information like an ID, a title, year, price, genre, and it has a foreign key to tie it to an author. So an author model shows us mainly the ID, the name, the ID of the record, which is kind of opaque. And from here, we can hit some routes in our API. So /API/authors, for example, we'll get all the authors. We can also get a specific author. And similarly, we could do the same for books. So now, what I'm going to show is where this is currently hosted. So it's currently hosted inside of Elastic Beanstalk, AWS Elastic Beanstalk. So let me open up my AWS Explorer inside of Visual Studio.
Yeah, while you're doing that, these are actual tools that we build here at AWS. These are tools to make the .NET devs world a little bit more like that they're used to when working inside of Visual Studio all the time. Now, Visual Studio is not the only place you have to work with .NET code anymore. You can actually, since the inception of .NET Core, you can obviously do this in Linux and in Mac and Windows. I often utilize VS Code personally, but we have a lot of tooling for Visual Studio itself built by a really cool .NET team at AWS. We're also, Chase, getting asked, could you zoom in just a little bit?
Ooh, that's a good question. I'm going to see if I can do that. Hey, there you go. There's me not using the right stuff. Keyboard shortcuts. That's a great question. If anyone would be able to chime in with how I might zoom in on Visual Studio, I would love to hear it, because we will be using Visual Studio quite a bit. But I have to say that I'm not.
Control plus I, they think. Succotash. Or control plus scroll.
Control plus scroll. I wonder if that works more inside of like text or something. Control I seem to. Oh, there we go. Hey. All right, we got something. I wonder if that works here too by any chance. Nah. So it'll be a little bit dependent, but certainly when we get into the code, I'll be able to zoom in. Yeah. Main thing is, I love using the AWS plugin here with Visual Studio, which makes it easy for me to kind of see some of my environment. This is where I currently have my API pulled up. And there's nothing at the root route, but if we dive into /API/books, we'll start to see where this will pull up records about our books. So we've got a number of books here and a number of authors as well. And, just as I mentioned, you could pull out a specific author. You can do the same thing here. This is all standard .NET Web API types of application functionality.
Yeah, Chase, would you mind? Could we take a second and talk about what Elastic Beanstalk is? I'd love, actually, Mo, can you tell us a little bit about Elastic Beanstalk? I'm going to put you on the spot.
Elastic Beanstalk. Yeah, you are putting me on the spot. Elastic Beanstalk is a great platform. I've used it myself for like hosting WordPress. I found it really easy. It was like completely managed for you. Didn't have to worry about scaling any of the EC2s or anything like that. I just kind of downloaded WordPress to Elastic Beanstalk, and it worked just fine. But this was a while ago.
Yeah, it's exactly what you're saying, right? It goes and sets up the EC2 instances for you. It sets up the load balancer in front of those for you. And then you just get to focus on deploying out your code, right? You're still running it in a server environment, so you don't get the same benefits as you do as running it in something like Lambda, because you're always on, you're always running. You're going to pay for those EC2 instances that are up. But yeah, it's probably one of the easiest ways to just push out a zip file and have it deploy out onto infrastructure without you having to really worry about that infrastructure.
It's in some ways a precursor to serverless. It tries to manage a bunch of the infrastructure for you, but it's compared to modern serverless approaches, it still doesn't scale quite as quickly, doesn't bill based on extremely tight units of utilization. So it did make things easier, but serverless is a next evolutionary step from there. So we have our API running inside of Elastic Beanstalk, but one of the things that I worry about with this application is that the authors route, I think it's the authors route that we're going to work on today, that the authors route doesn't scale as well as I would like it to. So I'd love to find a way that I can take this application and refactor just the author's route, or either the authors or the books route, one or the other, so that it will be served serverlessly while leaving the other one in place, meaning I don't have to refactor the entire application in order to achieve the benefits of serverless. So let's start by creating a new serverless app. I'm going to hop into Stackery here, and I'm going to create a new stack. So a stack is basically a representation of a project inside of Stackery. So I'm going to call this .NET Core Web API 3. You can see that I've practiced this a couple of times. We'll put this into Stackery. We'll make it public in case anyone wants to follow along as we are building this out. And I'm going to add this stack now. So what this is doing behind the scenes in the background is it's creating a new Git repository inside of GitHub for me. So I'll hop into here. There I go, hit the wrong button again. All right. Open it in a new tab. And we can see that it created for me this kind of blank looking template of a CloudFormation-based serverless application. So let's grab the URL to clone this. And now let's hop into Visual Studio Code. And actually, I'm going to create a new instance here for my new application.
I heard a wishful thinking there. You said you're going to hop into Visual Studio Code.
I did. Yep, I'm hopping into Visual Studio. Yeah,
Freudian there for you.
Yep.
I wish you were hopping into Visual Studio Code too.
I do love Visual Studio Code.
It's my fave.
The nice thing about Visual Studio, and one of the reasons I wanted to show this, is Visual Studio has some really amazing code completion and IntelliSense mechanisms that Visual Studio Code doesn't quite yet have for .NET applications. So let's open up our Git repository here. I think that looks like it's going into the right place. All right. All right. I think I'm going to say not now. I'm enjoying Visual Studio, but I don't need to give feedback now. Let's see. Thank you. All right. Okay. All right, I'm going to set up a couple of things. Because I am creating this in Visual Studio, just to make things a little bit easier down the road, I'm going to say let's ignore our Visual Studio folder, and I'll save this and just leave it there for the next time we start to push things up to GitHub. Now let's open up our template. So this is a CloudFormation or SAM template where we can define the infrastructure for our application. Mo, can you help us understand what's the point of CloudFormation or a SAM template?
Oh yeah, so CloudFormation, SAM, super great way to write infrastructure as code. With CloudFormation, in this case, I think it's YAML. So you could just write a whole bunch of YAML and have all of your infrastructure deployed in the cloud. And with SAM, it's a framework for serverless in particular that makes it a lot easier to deploy serverless applications using infrastructure as code.
Yeah. But one of the challenges a lot of people have when they want to build up their serverless applications and they're using infrastructure as code, whether it's for the first time or for the millionth time, is it's a very verbose language that's different than a lot of programming languages. So it can be tricky to figure out how to get started. One of the things that we can do with Stackery to make things easier is we can use its visual editing canvas. And I can do this locally. So I'm going to pull up PowerShell and go into my web API directory, and I'm going to issue the Stackery edit command. And this is going to load up the Canvas visual editor for my stack inside of my browser that I have here. So I'm doing this inside of Microsoft Edge today, actually. And I forgot
to had some interesting questions here in the chat. So number one, Tesseract says, why use SAM instead of just CloudFormation?
Great question. So SAM abstracts away a lot of what's challenging in CloudFormation. So if you're creating a Lambda function in CloudFormation, one of the challenges with it is you have to create IAM roles. You have to figure out how to create subscriptions for lots of events. And those are consolidated into an easier to write and an easier to read section of CloudFormation when you're using the serverless application model or SAM transform. So you don't have to use SAM, but it provides benefits there. But one of the even more powerful benefits with SAM is if I am adding a function here, and then I add in let's say an S3 bucket, and I want this function to be able to interact with the S3 bucket. So I wire it up inside of CloudFormation or inside of Stackery. What that does for me is I can use something called a SAM policy template, which isn't available in raw CloudFormation. The SAM policy template makes it really easy for me to specify a common set of permissions that I want to provide. Here it would be the ability to create, read, update, and delete objects inside of this S3 bucket, and only inside of this one S3 bucket when it gets deployed. You can do the same thing in CloudFormation directly, but it actually ends up being much more complicated because you have to define very specifically all of the CRUD style operations, and you have to know how to construct just the right syntax for the resources, the ARNs, Amazon resource names, to make sure that the permissions are scoped only to that S3 bucket. It's hard enough that if you go out and look at a lot of examples online, especially of other frameworks like the serverless framework, you'll see examples where people who need to interact with S3 buckets will just create permissions that look something like, oh, and let me zoom this in a little bit so that it's a little easier to read. Whoa, maybe not in increments of 100%.
Why not? I mean, we want to see
sure
one really specific case.
Yeah. Wow. Okay. I did not realize it would be quite so hard to zoom. Wow. Yes. Thank you. Apparently, Edge needs to figure out how to zoom at levels less than increments of 100.
So not only are you getting a really in-depth lesson right now, everyone watching, around how to build serverless applications, you're also learning how to do Windows commands with someone who doesn't run a Windows machine regularly. I think that's like a twofer, right? At least.
I think so. Oh, I just realized this is zooming my desktop. It's not zooming
that's a
Edge.
magnifier tool, isn't it?
Magnifier tool. All right, here we go. This is probably what I want here. This seems much more sane. Okay, there we go. All right. If I wasn't using CRUD policies, I'd have to write statements that are more like statements. What is it? Action would be, and then a bunch of S3 put object, S3 get object, and then I'd have to say resource is where a lot of people end up just saying S3 star. It's just too hard for me to specify this. Instead of, oops, see, I used the wrong command again. Instead of properly doing things like I need to get at the bucket.arn, but even that's not enough because I need to make sure that I have a way of referencing the bucket.arn plus / on the end. It gets really confusing and really challenging. So having these SAM policy templates makes things so much easier. So that's another reason why I love SAM. All right, so let's go back to building out our refactored application. So our application, our .NET framework, is a traditional monolith. It's got an API that has a database, a SQL Server instance where it stores all of the data. And to build this serverlessly, we are going to put an API proxy in front of the existing API, in front of this API that we were hitting earlier, and send some routes to it, and then start to send other routes that we build up to our new serverless version of our API. So we're going to start out by adding this HTTP API resource. API Gateway, which is where this comes from, actually has two different types of REST APIs at this point. Can someone remind me, what's the difference between the REST API and the HTTP API that we're going to use today?
Hey, I'm not falling into that trap.
I think the HTTP API is better for when the downstream. So if like you're using Lambda as a proxy, you're probably better using the HTTP API. It's faster, cheaper, better, according to Eric Johnson.
Yeah, it's got less features than the REST API version, right? Like there's
today.
Yes, today. I don't think there's what's the standard that you can write to generate an API.
Open API.
Yeah, I don't think it has support for that. I'm not sure on versioning support.
It does like actually. It does. Okay. We will actually, so what we've done here with our canvas is we have updated our template, and we see here this is the Open API specification that we put in. That crucially at first here, we're going to send everything that goes to the default routes. So basically right now, because we haven't specified any other routes, we're going to say proxy it to our existing Elastic Beanstalk hosted API. So this has a few extensions of Open API. That's what these Amazon Gateway keys are for. But aside from these extra keys, it is fully and proper Open API spec. So we use the canvas here to build our new HTTP API. And let's just make sure that this works, that when I hit our API through this HTTP API, that it will actually do the right thing. So I'm going to hop back to, actually, I'm going to open up a new instance of PowerShell. All right.
You got called out, Chase. I'm sorry to tell you. Yeah, you got called out big time.
What did I get wrong?
Well, it's about your cowboy hat.
Oh, no.
Yeah. It doesn't have a Vans logo on it. Nick Walsh is calling you out, saying that hat better have a Vans logo on it. Or I think he might eject you from the stream, actually, and he has that power. Nick is a powerful person around here when it comes to Twitch. He can kick you right off, I think. Is that right, Nick? I don't know. You let me know.
All
it's
right.
Okay. So Vans gets enough free advertisement from me.
All right, so I was just getting ready to deploy my stack, and it reminds me I'm going to deploy from my master branch, but I haven't committed what I've done to the master branch. So that reminds me I need to hop on back into Visual Studio and start to commit this and push it up to my Git repository. So let's do that. Let's go to our changes. Let's say we're going to add our API proxy. So we will commit this. And now I'm going to push the changes up to my Git repository in GitHub. Are we pushing? I think we're pushing. Here we go. All right, successfully pushed. So now when I go back, I can tell it, yes, please deploy from master.
Yeah, so we had a question. This is actually getting it from the source repository, not the folder. And the answer is yes.
Yes, there's a few things going on here. The first is when we're doing our local editing, the way that I ran the Stackery edit command to open it up inside of my browser, that's interacting with my local file system, which makes it really easy to rapidly iterate on my own source code. But then as I'm doing the deploy process, there is a mechanism. If I were to say Stackery deploy -- strategy local, then it lets me deploy by packaging up all of my template and function source code and everything on my laptop, ship it to CloudFormation, and then deploy it, execute the change set that's created there. But I like to do things by deploying through code build inside of my own AWS account. And the reason I like doing that is I know when I do that, no matter how I kick off the process, it's using a clean state every time, a clean code build image that's checked out. And it's also a good habit if you have, say you work at an enterprise. We have some enterprise customers of ours who have concerns around code confidentiality, meaning who has access to the source code, especially during deployments and packaging phases. And by building and packaging the source code for our projects inside of our own AWS account, we know that we've got that code confidentiality covered. So there's aspects where there's a lot of benefits to doing this. Sometimes local deployment strategies are what you want because it is ever so slightly faster. But generally, the benefits of having that code build clean image every time outweighs trying to do it locally. So what we just did here is we ran the code build job, and up at the top, it spewed out a lot of information, a lot of logs, where it was taking that template, finalizing it, injecting a couple of parameters, and then publishing that, uploading it to CloudFormation as a change set. CloudFormation then has that change set, and our CLI goes and asks to execute that. So now we have fully deployed out our new stack, and I should be able to take this API in API Gateway, and if we go to API/books, we should see that we get the same response back that we would get from API books in Elastic Beanstalk, because all that's happening is API Gateway is proxying that request back to Elastic Beanstalk. So you might be asking at this point, okay, what have we accomplished? Not very much. I've got the same functionality. But what we can do now is we can start to create new functionality backing that API to pick off and refactor some of these routes of our API. So I'm going to hop back into Visual Studio, into my application, my stack, and I'm going to create inside of this stack a new .NET project that will be our .NET Core Lambda function, where we will re-implement some of our routes of our API. So I'm going to create an ASP.NET Core application, and I'm going to call it Web API, so it has the same namespace and the same name as the existing .NET Framework project. I'm going to put it inside of my, I'm going to put it here inside of source. I'm going to create a new solution. All right. And I'm going to create this. Fingers crossed I got all the settings right to put it in the right location. I think there's one more dialog box. All right, we'll just uncheck that. And everything looks good. I need some Western music right here. Can anyone whistle a tune?
Not for the stream, no.
Not when you're on the spot.
Not when I'm on the spot.
All right. I am going to quickly, I want to double check that this put it in the right location. I'm going to flip to folder view to see how this landed. Awesome. Okay. And I'm going to hop into here and add a git ignore file, again, as we're kind of building up a C# app inside of Git. So let's do add new file .git ignore. And we're going to put in bin, obj, and packages. These are some folders that get generated when you're building a .NET Core application. Okay, so now we're getting set up. There's one last thing I want to add just to make things a little bit easier as I'm building a Stackery-based function. So there's a file that we can add called .stackery.config.yaml. And this basically gives some default parameters, arguments, anytime I run Stackery commands inside of this folder. So I'm just going to tell it that anytime we run the Stackery command, it'll be this, it'll be for the function named Web API, and the path to the template that this function will be based in will be 2 directories up. We'll see where we configure this in our infrastructure as code in just a little bit. So a little bit of foreshadowing here, but I just want to make sure that my file system is set up well before we get too deep. All right. So now, one of the things that this does when we create our first .NET Core Web API is it likes to create an application controller for a weather forecast route. So I'm going to open up our project. I'll switch over to the solution view as well. And let's try running this to see what happens. Trying to remember how to get Visual Studio to load our project. I wonder if it's, maybe I have to click it. There we go. I think that's it. All right. So if I say run here, in a minute, it will compile this and then open it up in a web browser, and we can start to see that we've got this weather forecast route in this API.
This is actually the .NET Core kind of changes to how the ASP.NET framework works. And there was a lot. It was like a complete rewrite of the ASP.NET framework. And it kind of functions similarly to Express in Node. Remember how I said that .NET takes things that they think function well and then just brings it into the C# language. I feel like this is one of them, because there's the same concept of middleware that exists as Express has. And the dependency injection container is built into this version of ASP.NET, which it's really easy to work with.
And for some reason, I am failing to remember. There we go. That is what it needs to look like. Now we're loaded.
There you go.
All right. I didn't have the project loaded properly inside of Visual Studio. Okay, so now in a minute, we should see that the API is loaded. It's building up. Everything here, by the way, this is going a bit slower because I'm just running this as I'm video streaming at the same time. So my laptop and Visual Studio and all of these tools generally are quite a bit quicker. So don't be put off too much by that. But we see here that there's this /weather forecast route that this .NET application, .NET Core application, is meant to host. So before we get too fancy and start to refactor our API, boy, this is taking a while to load. This is loading up. Oh, here we come. There we go. Now we've got some JSON weather data. And it's just statically loaded from a file, which is fine. But it's demonstrating we've got a .NET Core application with the Web API framework. And it works to run a basic API. So now let's first work on getting that running inside of a Lambda function without trying to re-implement any routes. So now it's time to wrap this inside of a Lambda function in our CloudFormation or serverless application model template. So I'm going to hop back into Stackery, and let's open up, or let's add a function here. This is where we're going to call this function Web API. We're going to set its runtime to .NET Core 3.1. I'm going to put it into, or I'm going to say that it already exists inside of the source/web API folder. And for the handler, I'm going to put some stuff in here that looks a little cryptic, and again is going to foreshadow what we're going to create in a minute. So this says within, and I think I'm going to get this right, but if anyone is a .NET or C# aficionado and I screw this up, please chime in and let me know. But this is going to load the handler in Lambda from the Web API package and the Web API namespace within that, the Lambda entry point class, and then the function handler async method that's implemented inside of that class. So we're going to add some source code and some packages in a minute to be able to host that. So I'm going to save this. And now I'm going to add a new route to my HTTP API. Get /weather forecast. I believe that matches forecast. / weather forecast, and we'll save that, and we'll wire this up. So now if we take a look back at Visual Studio and I open that template.yaml file back up, we'll see that we've added our web API function and we've set it up to handle / weather forecast routes from our HP API up above. So we're getting there, and we've defined the infrastructure and how it relates to our function. But now we need to add some code to our function because this isn't going to run on a server as a process like a normal .NET Core application would. Instead, it's going to run in a Lambda function, receive events. So here in Visual Studio, I am going to add a new class inside of the Web API folder. I'm going to add new file. We're going to call it lambda entry point.cs.
I have a feeling that Chase is getting into another area of a piece that was already developed by AWS over here, by specifically Norm, one of my favorites over on the .NET team. Am I?
You have favorites?
Of course, I have favorites. I have favorites of everything. We all have opinions, right? I mean, that's why we're on Twitch. It's to share these opinions, right?
Right. So that's exactly right. I love this package. And if you search for Amazon Lambda ASP Net Core Server, you'll come across this package that is open source, created by Norm over at AWS, and it lets us run an ASP.NET Core server inside of a Lambda function. Now, this is going to create what some people call a Lambda lith or a mono Lambda, which is a portmanteau of Lambda functions and monoliths. And that may not be the ideal way to run an application. A lot of people like to run APIs where every route of an API has its own function implementation, which can make testing easier, maintenance easier, startup faster, and so on. But especially when you're refactoring existing applications, it's non-trivial to start by breaking everything down into separate functions. What this package lets us do is run a full ASP.NET Core application inside of a Lambda function without doing a bunch of conversions of it. So I'm going to take...
One second before we move on. Sorry. Mo, who are we? What are we doing? What is this crazy place that you may have stumbled in if you're watching us right now? What's going on?
We're in the wild wilderness. We're in the wildest wilderness. This is Howdy Partner. We have Chase here, CTO and co-founder of Stackery. He's teaching us all about how to design, develop, and deploy serverless applications in the best possible way. Right now, we're actually refactoring an existing application that was in .NET running on Elastic Beanstalk, and we're moving bits and pieces of it to serverless. Is that an accurate recap?
That's exactly right. Yeah.
I think you missed, and you asked this question in chat, Mo. You missed the most important part. What is a .NET?
I'm not sure.
And at this point, are you too afraid to ask?
This is as close as I've gotten to this .NET thing that I've heard you talk about often, and this is probably as close as I ever want to get to this .NET thing that I've been talking about.
It's fair. It's fair. So I just wanted to say too quickly before we move on. Chase is using a lot of the tools that were built for AWS.NET devs by our .NET team here at AWS. Namely, one Norm Johansson. He's a personal hero of mine. He once starred a repo on my GitHub account, and that just months of dopamine was released into my brain when that happened. I was just so proud. it's a really like not useful repo either. It's not even something to be proud of. So I don't know why he started, but I love Norm, and he builds a lot of the tools that .NET devs that are trying to utilize AWS services end up utilizing and not knowing that Norm built them. So I always like to give him a shout out. He also built something that Chase isn't showing. If you're more comfortable on a terminal or command line program, maybe you're not working in Visual Studio. Maybe you're working in another IDE or not an IDE at all, maybe just a text editor, and you're working in the terminal. The .NET team at Microsoft actually built what's called the .NET CLI, right? And it's just a command. It's all lowercase .NET, like I just dropped into chat. And Norm has built on a bunch of extensions to this .NET CLI to work with Lambda. We actually generate a lot of the boilerplate projects, just like the one, Chase is actually showing you something really interesting here that we don't get to see very often, where you are inserting it into one of the projects that Microsoft loads up, or an existing project, something like that. But if you're starting from scratch, maybe you're playing around with Lambda and .NET, you can actually use these .NET CLI tools that I'll link to here in just a moment to generate projects, to deploy Lambdas, to do all kinds of stuff. But yeah, I think all those tools play really well with Stackery as well. So.
Yeah, they do. And just to reiterate, we're playing around with .NET today because I thought it'd be interesting to not focus on JavaScript, Node.js, or Python, which is the common focus for applications written with serverless, just to show that people with different languages can benefit from serverless as well. And we're showing how to refactor an existing application rather than creating a new application. So we're at the point where we have the beginnings of a Lambda function that uses or is implemented in .NET Core as a web API. And I plopped in some source code from Norm's amazing ASP .NET Core server package. Of course, once I've done that, we start to see that I've got undefined references because I haven't installed the package that contains all this amazing code. So
Jace, do you want to talk through like what this package actually does? Or do you want me to give a quick highlight?
Yeah, why don't you give a quick highlight while I install the package here into my project?
Yeah, Norm's piece here is actually really kind of ingenious. So like I mentioned earlier, there's a full rewrite of ASP.NET with ASP.NET Core, and introduced a lot of these middleware concepts that exist in other languages and have for a while. But you actually, each request that comes in now to the Kestrel server that is bundled with, you don't actually have to use Kestrel, but it's the built-in server now instead of hosting on IIS like you would with a traditional ASP.NET app. It's got middleware that each request runs through, and before the request actually gets to your controller, it hits all this middleware. So what Norm did was, Lambda has a similar kind of invocation event, right? Like a trigger, what we call it, or an event source. And that passes in a JSON object to your code that gets run when the Lambda function runs. So Norm took the REST API event and built like a proxy for the Kestrel server that essentially, it looks like we lost Chase's video there for a second. He'll be back. But it proxies the Lambda event through the actual ASP.NET Core web server. I don't know if we just fully lost Chase. We still have his screen, actually. It's kind of interesting.
I think we just lost his video feed.
And his audio, too. Not seeing his audio here. So I could just keep talking about what this ASP.NET Core server is. Like I said, it just takes the Lambda event that gets, that is actually triggering your source, your Lambda, to run your source code, and translates it to a ASP.NET object. There we go. Now we totally lost. So I'll kick over to just me and Mo and a blank screen. Mo, how's it going? Are you loving this? Are Are you loving this .NET world that you've been thrust into?
I'm loving the Stackery part of the .NET world. That's all. That's all it is.
Fair enough. Oh, Chase, you're back.
Yes. Anyone familiar with that famous Microsoft demo where Bill Gates is on stage and he gets a kernel panic as he's demoing something at one of his huge conferences? I feel his pain right now. My Windows laptop went into a kernel panic, so it is rebooting.
Very nice.
Yeah.
Chase, can you jump over a chair like Bill Gates can?
Can I jump over a chair?
Have you ever seen that interview? He was doing an interview, like a press interview, and
do you mean like this or something? Like
no, he jumped over the entire chair. Yes, yeah, just like that, except he from a standing position. He just jumped over the chair.
Man, I don't.
No, don't hurt yourself for the stream.
I don't know.
It's not worth the views. I mean, although it would probably pump the views way up if you fell on camera. It'd be great.
I had to Howdy partner my laptop so it could tell who I was.
Oh yeah, you had to take off the hat's not part of your identity?
No.
No.
All right, let's see how long it takes me to get reset up. Again, I apologize to everyone out there doing their best to follow along.
That's okay. This is my wheelhouse right here. It's called vamping and filling up time. It's what I'm good at. So Mo, what for anyone joining, what are we doing? Or shall I take this recap? You've been doing all the recaps today.
Yeah, you take this recap.
Okay, so we are collectively Wild Stallions. No, just kidding. We're Howdy Partner. We are a show all about bringing on the AWS APN partners and showcasing what they can do. We've got Chase Douglas here, the CTO and co-founder of Stackery, which is a product that really helps you build and deploy serverless applications at scale and within teams, right? So it's really easy to get started building a serverless application for the first time. There's so many different materials and tools for doing that. But then when you actually get into the pace of doing this for production and at scale with larger teams, you need something more reliable. Some CI/CD, some areas of help. And Stackery is one of those options that you can actually utilize to make that more I guess reliable, or what would you call it, Chase? Dependable?
Yeah, so we're not like a specific vitamin add-on that's going to make your serverless solution faster or cheaper or whatever. We're a solution, a platform for your entire software development lifecycle. So when you've decided that serverless is the right approach for you, and honestly, I can't think of many reasons why you wouldn't. When you've decided that that's the right way to do it, and you want someone to help make it super easy and fast and reproducible from a development standpoint, that's where we come in.
Yeah. Tesseract has a question for you, Chase. Is it possible to reuse portions of templates for other stacks?
That's a great question. It is possible through a couple of mechanisms. One is nested stacks. So if you have one Git repository, you can have subdirectories with different functionality, and you can reference that around. Another mechanism is by creating these what are called serverless applications that can be hosted inside of AWS serverless application repositories. You're basically uploading a template and source code to AWS SAR. Those can be public. They can also be private. So they can be something that you just have privately for internal use, or if it's generally functional, generally helpful for anyone, you can host them publicly on AWS as well as little templates that you can pick off and choose.
Yeah, I'll say, there's like 1,000 different ways to do essentially CloudFormation or some sort of CloudFormation pattern, like be it, Terraform or some other, type of infrastructure deployment tool, right? So it really just comes down to what you all are looking to do. But I think working with Stackery means that you'll be working with CloudFormation either through SAM or through CloudFormation itself too. And there's a lot of options for how to work with CloudFormation at scale too.
All right, okay. I am doing my best to try to install our.
All right, let's get your screen back up. Yeah.
But my project may be in a wonky state now because I can't seem to install the package, but the package doesn't seem to exist. So let's hop into PowerShell here and see if we can find let's see, let's open up our CS proj file. Come on. Ooh, everything is starting to have a hard time. I wonder if something's a little messed up in the Visual Studio. Oh, here we go. Okay, it's loading up. Source Web API. If I open up the CS proj, is the package in here? Okay, it's not.
Oh, no dependency yet.
Add package Amazon.lambda.
Chase is using that .NET CLI here.
I am.
Yeah.
We'll see if this works a little bit better. Looks like it might be. The content at, oh no, is there something wrong with NuGet right now? It says it's not a valid JSON object. ASP. I wonder what happens if I go to this address out of curiosity. Live demos.
This is it. That's why. This is your live demoing. You could also use the UI in Visual Studio.
I had been trying, but it likewise was throwing an error. Yeah, so, or it wasn't even throwing an error, it just wasn't working. Let's reload the project. Yes. Now let's manage NuGet packages.
Yeah, there you go.
Amazon Lambda ASP.NET Core Server. There it is. Let's install it. And yeah, it just kind of dies there. But our errors list is smaller. Let's open up Lambda entry point. Oh no, it still can't find that package. Okay, so .NET add package. Is your PAL norm available?
It's interesting.
Found invalid data while decoding. Oh, there's a cache here that it's hitting. And I wonder if this...
Are you on any kind of network?
How do you clear? Well, it may be cached locally. Any Twitch users have any suggestion for how to clear your NuGet cache? Let me see if I can find something. Let's see. Locals command. NuGet locals. .NET help. .NET NuGet locals help. Let's clear our clear. Let's do the HP cache. Let's see if that might have done something. Nope. Let's try clearing all, or I think there's a temp cache.
We got two. Oh, okay. So you can manually remove the NuGet cache from user profile / NuGet / packages as well.
All right, so that would be in users. Where did you say it was?
There's actually, so on the same link that that dev_Dole copied, there's a way to do it through Visual Studio by just going to Tools, NuGet Package Manager, General, then clear all NuGet caches.
Let's see, the manager console, I'm guessing, or the settings. Let's see. Try the console.
Tools, get Package Manager, General.
This might just be the console. Let's try Tools, NuGet Package Manager. Oh, here we go. Clear all NuGet caches. Let's try this.
One.
Hold on to your hats.
I have a literal one to hold on to. That's great. You do too, Chase. Hey Mo, I'm noticing something.
I know.
Here. What's missing? What's missing, Mo?
I have brand affinity too, and apparently
it's no hat.
No hat.
Hey, it's working. We're getting there. Nice find, Mo. That's awesome. Okay.
That was the chat, right? Who said that in the chat? Somebody, right? We got to give some credit. Dev Dole. We got to give him some credit too. Yeah.
Awesome. Nice. Okay. I'm going to have to go a little bit faster, I think, through the rest of the content because of the time we lost. But we're back on track. So we have everything we need here. I need to make sure this is in the right namespace. But we've gotten rid of all of our errors, all of our warnings. We now have our Lambda entry points. And there's one last bit. Because we are using the new HB API with the new payload version 2.0, we have to use the proper class for handling that style of input event. So I'm going to swap out the class that would handle REST API or API payload version 1.0 with the version 2.0 as our base class. So I'll save that. And now it's time to commit this and push it up. All right, does everything look good? Everything looks good to me. So add function code. And we'll commit. We'll sync that up. Push it up to master. And we will do a Stackery deploy and wait for that to deploy out. So as a reminder, what we've done here, beyond crashing a Windows laptop, is we have, actually I'll pull up PowerShell because we're going to need it in a minute anyways, and we'll open up, we'll re-edit our templates. So sources, Stackery edit. All right, so we've got our HTTP API. We're sending default traffic to our original server, which is a .NET Framework application that is hosted out of Elastic Beanstalk and can grab records from a SQL Server database. And we've added an additional route. So actually what I should do is, well, we'll see it as this deploys out. We've added an additional route to hit, when we hit /weather forecast, it will run our web API function with a full .NET Core web API application in it, which by default just comes with this route. And we'll see that we were able to proxy and deploy that out, or proxy and hit that and run that function just as though it were hosted off of a server. So we're almost deployed out. We're using code build through Stackery to package up our stack. And now a CloudFormation template and change set was created. Now we're executing that change set, which is going to create our function and is going to create the API route so that when that route is hit, our weather forecast route is going to invoke our function.
Yeah, you mentioned this earlier, but we kind of glossed over it a bit. Stackery also has a CLI, because what developer tool is complete without a CLI, right? Can you tell more about what the CLI is there for?
Yeah, the CLI, certainly it helps you run commands to manage your resources, like your stacks, your environments, your deployments, and so on. But it also is helpful for doing local development iteration. If I wanted to run my function locally to debug, I can use the CLI to run that inside of a Docker container, for example. But as we do that, I can download credentials for that function and download environment variables for that function as it's deployed into a specific environment, which gives me the ability to locally and rapidly iterate on a function while hitting real resource types like DynamoDB running in the real AWS account.
Yeah, that's one of my favorite features. I love that. That's one of the coolest things that you all do. And it addresses exactly what Mo was talking about at the top, right?
Yep.
Mo was talking through how we can't really feasibly mock everything, right? Like, and not get the same type of environment as we do when we get the cloud. Right. So you all don't. You all just can actually hit the pieces in the cloud that we're actually trying to work against.
Yep. So you'll notice here we've deployed out our stack. And it created these two routes, the default route and the weather forecast route. So when I hit weather forecast, it's clearly hitting our Lambda function that we created. But if I hit API books, it hits our original .NET Framework application running inside of Elastic Beanstalk. So now we are ready to start converting over some of the controllers and models and routes of our existing .NET Framework application. So I'm going to do a couple of things here. The first thing I'm going to do, I'm going to hop back to Stackery here. And we're going to convert the books route. We're going to leave the authors route, but I'm concerned today that the books route is really slow and doesn't scale well. So I want that to be re-implemented inside of Lambda and not worry about having to re-implement authors. So let's put a new route, not patch, but any, for API books and any on API books proxy plus. This is a fancy way of kind of saying /star. So anything under /API/books. So these are the two routes we're going to add. Save that, and then I'm going to direct those two routes to our web API function. And again, every time that I wire things up inside of the Stackery editor, it is editing the CloudFormation SAM templates. So it keeps all of that in sync for us. And just in case you're curious, if I were to edit anything here, we would see it reflected back in the canvas. But due to lack of time, I'm going to jump over that and continue on.
We did have a question real quick. Are both projects under one repo?
They are not. And so they could be. There's nothing that prevents it from being that way. But today I'm just showing them as separate repos for simplicity.
Sure, makes sense.
So I've got a database here, and I mentioned that we already have an existing database. So I'm going to hop into my AWS Explorer and find the existing database that I've got. And if I open up the properties for it, I'm going to grab the endpoint here. I'm going to paste it in here. I'm going to grab the port 1433. And just in case this were ever deployed out, I'm going to give it like a temporary initial password, which isn't going to be used because we are using an existing RDS database. It's just for validation purposes for the template. So now I've got a database that references my existing database. I'm going to wire up my function to it. So now my function can make connection requests to it. But when I connect to a database, I also need credentials, like the password. So I am going to add the ability for this function to get secrets from Secrets Manager for the development environment we're going to deploy into. You might have been here earlier when we took a look at the environment support inside of Stackery, where I'm able to specify parameters and specify secrets that can be referenced inside of an application, a stack. So I already have a DB password secret inside of Secrets Manager here.
I was going to ask too. This came up earlier, and I was fielding some of it. They were specifically asking about containers, but this could also apply to Lambda functions. Not to put you on the spot, we can also table this question. But are there recommendations that you have for working with Secrets Manager with rotating secrets and having that update in your Lambda functions, things like that?
Yes, ideally it's a best practice that you should use. Though I think it's a bit more nuanced and complex than we've got the time to jump into right now, unfortunately.
That's fair. That was kind of my answer too, was that it's dependent on how you're actually utilizing those secrets? Are you doing it in code? Are you doing it as environment variables? There's all kinds of things to talk through. So yeah, fair enough.
Yep. And so what I'm wanting to do here is open up the original .NET framework. I'm actually going to add this for right now to my solution, just so that I can quickly copy files back and forth. I'll have to delete it later on to not confuse .NET CLI as we package things. But for right now, it's going to make it easy for me to copy things. So we have models for the author and the book. That's in our existing library framework application. I'm just going to paste that whole folder, copy and paste it over, because I don't have to do anything. That works between .NET Framework and .NET Core, no manipulation. The data folder has this web API context, which is used for specifying how we connect to our database. So I'm going to copy this folder over as well, but we are going to have to make a few modifications to it. First of all, we're going to have to modify it so that, I'm just going to quickly remove unnecessary usings. We're going to have to modify it so that it uses the new entity framework core instead of the original entity framework. So we're going to install Microsoft Entity Framework Core. So let's do that. Hopefully this doesn't crash Windows again. Okay, now I'm going to add some data so that we can grab the database password from Secrets Manager. So private task get secret value response, secret response task. And it's telling me again, well, wait a minute, I don't know what this get secret value response is. But if I click on it, we'll see that, so first of all, we need to use system threading's task to get task here. And now we need to find and install the latest version of the Secrets Manager password. So we'll do that. This will let us make calls out to AWS Secrets Manager.
So this is an interesting approach. You wouldn't really have to worry about your rotation schedule or anything with these secrets, since you're actually calling Secrets Manager directly from code, which is what I was advocating that you do as well, because that you don't have to worry about how it gets aligned as an environment variable, or if the password gets rotated and how that changes, et cetera.
Yep. All right, and then we're going to create a new client here. And I'm going to, let's see, what am I missing here? We're going to, using Secrets Manager. And let's see. Now I'm going to set my secret response task to the task returned as I set up getting the new, or the database secret. Actually, I'm already using that. So model.get secret value request.
So we had a question from Eco. I'm guessing at the pronunciation there. You deployed that .NET application to Lambda, but how did API Gateway understand which application to use? And while you're hacking away, Chase, I'll take that.
Go for it.
You're actually deploying out an HTTP API that acts as a proxy. So any request that comes in is automatically proxied to that function that Chase deployed as his ASP.NET function. So, all routes essentially are handled through the ASP.NET Core framework. So if you don't have a controller that matches an API endpoint for that HTTP API on the AWS side, it'll throw like a 404 or whatever status error that ASP.NET Core will. Does that make sense, Eco or Ico or however you say your name?
EG89.
And the last thing we need to do is do a protected void on configuring. So we're overriding a little bit about this. This is supposed to take options builder. I'm trying to remember. Let's see, options builder. I believe that's hit the wrong keys on my keyboard. All right, so on configuring takes an options builder. Yeah, let's fix that. Probably need a usings. Something I don't remember doing this. But
on configuring is usually an entity framework thing.
Yeah. I don't remember having to do this, but we'll try it anyways. We'll just install this.
Eco, yes. The API gateway proxy route got hooked up to that function with an ARN in the YAML template.
All right, so we're getting the password from Secrets Manager. We're also going to get the address. And we're going to get the port.
Chase furiously types away. I'm going to drop in. This is a GitHub link to all projects .NET focused from AWS. This is a great place to go to see what's available.
You're not going to convince me, AM.
Hey! Okay, that's fair. I can't. They actually, so what made me think of putting this in is there is a secrets manager caching layer built by this team. I think it's pretty neat.
I'm going to add my SQL Server driver. And that should be the last package we need.
Chase, you were going all out for this .NET demo.
I know, yeah. We're running out of time, though. Getting so close.
We can go over. I don't think anybody's on after us.
I blame Windows kernel.
We've got complaints about how furiously you're typing, Chase.
Complaints.
yeah, it's deafening. Is the phrase? I think it shows how dedicated Chase is to getting this .NET project to work. Which this is not Chase's primary language. It's not even his secondary language, if I may be so bold.
I do enjoy it, though. I do enjoy it.
Says this is the most ambitious Do It Live demo I have ever had the honor of watching.
Awesome. I appreciate that. All right. We're close. Did I set this? somehow this auto-completed incorrectly. Where is this? Yeah. This should be secret ID auto-completion. Jeez. Okay, there we go. And this should be data source equals DB address. This is some magic like .NET framework foo here. How you set up the connection string.
This is entity framework, which is even deeper magic than .NET framework. For anyone watching not familiar with .NET, entity framework is .NET's ORM, or object relational mapper. So it takes models, translates it to SQL, or it actually works with a number of databases. And so you can only deal with working with the model and code. You don't have to worry about writing the SQL statements to update or delete or create or any of the things.
Pretty cool.
There we go.
It can be cool. It can also be really, really difficult to work with sometimes. It will make some SQL queries that are not as efficient as they could be.
So we're getting somewhere. We have our connection string generated, which contains our root DB or our database password. You really shouldn't use a root password or a root user for this, but we're going to do it today because why not? You only live once.
YOLO.
YOLO.
Chase is YOLOing. I love it. With the cowboy hat too, I think really adds another layer onto that YOLO.
Oh yes, yes. So now we've got a connection to our database, and it is time for us to port one of our controllers over. So we're going to port our books controller over. We're going to leave our authors controller. We're going to port our books controller over. If you remember, when we were editing our functionality for API, we're sending anything under books to the API, and anything else, including the authors route, will keep going to the .NET framework application. So inside of our books controller, we're going to have a lot of issues that are going to be flagged because this is written in .NET framework, and we have to upgrade it to .NET Core. So the first thing I'm going to do is I'm going to clean up our usings. So remove a bunch of stuff. We can always add back in certain things that we'll need that are from .NET Core instead of .NET Framework. I'm going to upgrade this to use the .NET Core controller instead of API controller. And I'm going to decorate this class in the .NET Core fashion, like so. All right, and I should mention that this is all going to seem very magical, but if you search for ASP.NET Core migration for controllers, let's say, you will find all the things that I'm going to do here inside of documentation that Microsoft has. So it's not, actually this is it, Web API. So it's gonna look very magical what I'm doing, but I basically condensed a lot of what's in this section into just the stuff I'm gonna type into Visual Studio. So API controller, let's fix our import here. So we're gonna use that. And now, we have to go through all of our routes, and we're going to annotate them. So HTTP get, because we are getting books without any kind of ID. Here will be an HTTP get on the ID as a parameter. We also need to change this to IEnumerable. And we'll have to fix its usings. This here, the dot include, yes, we need entity framework core. All right. This here, we don't need anymore. And this, we switch to action result. Action result of type book. All right, so we're going to do this just a few more times. In fact, for right now, for time, I'm just going to remove a bunch of this, bunch of things that just need to be updated so they would compile. No content.
Chase, you're getting massive respect from the chat for coding all of this by hand. Got to share the positivity. Got to keep you going, right? I mean.
Yep. All right, and I think that's it. Do I have an error up here I got to resolve? Probably one more using. Yeah, looks like it. I think. No, that's not what I wanted to do. Do I have something? Oh, no, it's there. It's working. Oh, no, it's not. What is route?
So like you might have a collision, like of namespaces.
I wonder if that's the case. Let me look at my existing known working thing to see if there's something that I'm missing here. Source.
Is this CDK? No, this is not CDK. That's a fair question. It's been a while since we last introduced the show, right? Yeah, I'll take care of it. What we're doing right now is we're watching Chase teach us how to refactor a .NET app and make it serverless. So long story short, there was this .NET application that was running on Elastic Beanstalk, and Chase is doing all the heavy lifting right now to move it over to serverless.
And he's using Stackery to help, right?
He's using Stackery to do it, which is showing us all the wonderful ways to design, develop, and deploy serverless applications. Test direct. Question there.
There we go. Fixed my using statement, and we should be good now. So
nice.
We're going to try this once as we're running out of time. What are the odds that this works? What are the odds that this works? I'm going to go to Team Explorer, and I'm going to push up my changes. All right, add port over .NET code. Commit this. Oh, yes, let's save everything first. Oh, I forgot one thing.
Uh-oh.
We have to go to our Solution Explorer and remove our framework project first. So let's remove that. We only had that in there to make it really easy to copy things across. So now we'll go back to Team Explorer, remove .NET Framework app. And now we'll sync and push it up. Initiating push. All right. Let's deploy this out and cross our fingers, and we'll see that the route that we built for books, the routes for all of the routes under the controller for books will be re-implemented in .NET Core. So to recap the goal here, we started out with a .NET Framework application that was hosted in Elastic Beanstalk. This is an example type of application where people may have existing systems that they can't throw away, but they can't scale it very well. Maybe they've got bursty traffic patterns, like randomly, all of a sudden there will be thousands of requests to your service at different points of the day. You can't predict it, you can't account for it. So all you'd be able to do with Elastic Beanstalk is ensure that you're always up at the max possible utilization that you might see. But that gets very expensive very quickly as the servers are running 100% all the time. Instead, maybe what you can do is leave most of the routes, but if you can identify that there's only 2 or 3 routes that are hit with a high rate of throughput when there's a spike, then you can take those routes, you can pick them off individually and using API gateway. So here we're just picking off the books routes and we're leaving the authors routes. And we're re-implementing those book routes in a serverless fashion using this web API function. So we then showed how, after constructing this canvas of that turns it into a CloudFormation SAM template, we ported our .NET Framework books controller and how we connect to the database. We ported that to .NET Core using a API or ASP.NET server package that lets you run an ASP.NET server inside of a Lambda function. So now that we've ported that, we're deploying that back out, and we're going to test here in probably another 30 seconds that when we hit the books route, we see the results come back from our Lambda function, which will know, curiously enough, because .NET Core returns results to modern browsers as JSON, whereas .NET Framework returns results in XML. So that'll be the key that gives us an insight onto which of the 2 API implementations are returning a response to us. If it's JSON, it's our new serverless .NET Core function. And if it's XML, it's our older ASP.NET Framework solution running on Elastic Beanstalk.
Yeah, I wanted to call out too. I think there was a little confusion earlier, Chase. That visualization you keep showing. Will you switch to that real quick in Stackery?
Yes.
This actually generates the CloudFormation for us, right? I think that was a little bit confused earlier. That you can actually drag and drop, and that will alter the CloudFormation template underneath. So you don't write YAML, you don't write JSON, you don't write anything. In fact, you can vice versa update your YAML and then have that reflected in the visualization tool in Stackery. But you can also just only manipulate your infrastructure choices through Stackery's visualization tool and have all of that YAML generated, or JSON, whatever, generated for you.
Yeah, for example, I've got this /weather forecast route going to my API function. If I get rid of that in my template, do one more spot here, and I save this, this will update, or it should, any minute. Of course, live demo, it doesn't. It's showing me up. But if I refresh this, we'll see that it's fully reparsed out, that that route no longer exists. So it goes back and forth both ways. Yeah, we see here that it goes back and forth both ways between the template and the visual editor in the canvas. So we have deployed our function out, and now it's time for the ultimate truth. If we hit this books route, what ends up happening?
I don't know.
We get our books back in JSON from our Lambda function.
All right.
And if we hit our authors route, which we did not re-implement, we should get our authors back in XML because it's served by the Elastic Beanstalk. There we go. There are our authors. So we have learned today how to pick off individual routes of our .NET framework application, re-implement them with a little bit of source code modifications and some packages from our friend Norm at AWS, who figured out how to run an ASP.NET Core server inside of a Lambda function. Piecing that all together with API Gateway, picking off these routes, we can re-implement individual pieces of an application without rewriting the entire application. And we learned how to crash Windows at the same time.
That's right. Yeah, you kernel panicked. That's pretty monumental, I think. I just put up the links too. So if you're interested in signing up and checking out Stackery, there's a link there, and also you can actually request a demo of Stackery as well, I believe.
Yes. Yeah, I wanted to make sure people knew as well that if you're building applications as part of a team, or you're wanting to modernize existing applications in similar patterns to what you've seen here today, there's a lot of challenges to building up applications the right way. Stackery as a product makes this much easier than having to figure it out on your own. And we didn't even touch the points today around CI/CD, which Stackery has mechanisms to help with, giving you preview deployments, functional testing end-to-end, giving you the ability to have all of these namespace mechanisms for deploying and managing all of your environments. If you want a demo of how to tie all that together, there's a link posted there, and we're happy to show you how all of that works as well.
So we had a question from chat too. I'm dropping in the GitHub link to this project that you were working on today, Chase. Is this, so Denny asks, is this an efficient way of running a .NET app in Lambda? I mean, that's number one, a loaded word, right? Efficient. What is efficient in what sense, I would ask first. But I would argue that no, this is probably not the most efficient choice of how you run a .NET application in Lambda, which actually .NET Core is one of our faster runtimes as well, just from benchmarks and metrics and things like that. But this is the question that I get, I think, all the time from .NET devs is we have this pattern where you can spin up a full Kestrel server that proxies the event JSON and translates it into an ASP.NET Core object that goes through the full ASP.NET Core framework, right, middleware and everything. Is that efficient, right, to run for every endpoint, to run for, et cetera, right? To make this mono, what would you call it, a mono Lambda? Is that right?
Lambda-lith.
Okay. Which one is going to win, by the way? We need to figure that out, too. But that's probably not the most efficient way of doing it, right? But it is a way to get started today on existing applications, or even just writing a new application in a pattern that you already know how to work with, right? I think a lot of people, they go for optimization way too early. You know what I mean, right? They don't use existing skills to start building today. They over-index on how do I actually optimize this way before I even need to. I think it's very feasible to write an application this way until it's not, right? Until you need to hit the scale of breaking out independent API routes to their own functions, fronted by their own path in an API gateway, right? And then decomposing further there, right? Maybe you need to break things out into different microservices. Maybe you have one API gateway fronting all of your services, and now you need to break it into, well, we have a users and authors and a books API gateway that point to different functions. But I think obsessing over that and figuring out what's the optimal way to build your application really gets in the way of you building the application. What do you think, Chase?
Yeah, it's really about giving people lots of places where they can onboard. So if it's easier for you to get started by just porting your entire application over, then you can do things like turn up the dials on how much CPU and memory are allocated to the function. And then it'll run very quick, very fast. And when you get to the point where maybe it's so high throughput that it is worth value to your business to run that at lower memory and CPU utilization, then you can take the time to refactor it into being less code that starts up. There's actually a lot of techniques you can use to improve the startup and the execution speed, especially of .NET applications, including ahead of time compilation patterns and other functionality. So this is a great starting point. It's the easiest way to get an existing .NET application into Lambda. You don't have to stop there, but you can. And so it's just about meeting your needs wherever you are. In fact, you may even find that you've got an old .NET application that was written by a team that no longer exists, and you have to maintain that. But .NET may not be your runtime, and C# may not be your language of choice, and that's okay. You can leave that .NET application server as it is, and then pick off individual routes and rewrite them in Node.js, Python, Go, whatever your favorite language is. So you've got flexibility there as well.
Yeah, we had a few questions come in. The maximum size of a function 200 megabits? No, I don't. That's not true. That might be the maximum size for like an inline function or something like that.
So if it's the source code package size, I believe it's 50 megabytes compressed, and maybe something like 250 megabytes uncompressed. So there are some size limits there. You can look at ways of offloading, and like say there's assets. Can those assets be loaded and maintained inside of an S3 bucket, let's say? Yeah, that's one mechanism. There's a lot of different ways to kind of manage that too.
Yeah, I thought that was greatly raised with S3 bucket storage. The other one was around authentication and how do you add authentication to your routes? And I bet there's you do that pretty easily with Stackery.
Yeah, so I can add a user pool, which will hold my records of users. Sorry, scrolling's a little wonky because of my mouse. And I can add a user pool client, which lets things like APIs interact with my user pool. I can add an authorizer to my API. So we'll call this my auth. We'll make that the default authorizer for my API. And now I can wire up my authorizer to the user pool client, and that all gets stored inside of my Visual Studio, inside of my template.yaml file. So if we scroll down, we'll see that a bunch of stuff was added, the user pool client, and that's connected to an authorizer up here. All of this is managed automatically through the magic of Stackery's development canvas abstraction.
That's awesome. That was so easy.
Yep.
Click and drag.
Super easy in Stackery.
Like 50 lines of YAML.
Yep. 50 lines of complicated YAML. Who wants to figure out to add an authorizer, you have to specify which header it's going to be in, the authorizer header or authorization header in just this format, and that you have to specify JWT configuration where the issuer is the string that you have to create by combining a bunch of stuff. And the audience based on the user pool client. It's a mess. It's challenging. It's all possible to do by hand, but everyone's going to spend a lot of time if the best tool they have at hand is manually trying over and over again how to build the right infrastructure as code. So that's why we built Stackery and its visual editing canvas.
Yeah, it's awesome. I love it. I use it all the time. Tesseract, I wanted to call out, had a really great point, kind of around these limit ideas of storage and everything. If you are really approaching a function that is huge in any respect, right? Like let's say it uses all 15 minutes of timeout, or it's utilizing the entirety of the memory that you can allocate to a function, or it's a large package size. You're really kind of approaching, is this a function, right? That's what Tesseract. Wouldn't it be better suited to run in a container or on EC2 or some other method of deployment? Or would it benefit from you at that point optimizing, right? Like trying to break apart these things. So I think that's really the key point here, is not how much, what kind of limit should I approach, is as I'm approaching those limits, am I doing the right thing, right? Am I still in the realm of writing a function, or am I really just writing what should be a server-based workload and trying to make it into a function? Any thoughts on that, Chase or Mo? What do you think, Mo?
I mean, yeah, I think you hit the nail on the head. Can't add anything to that. Yeah, Chase?
Yeah, it's really about optimizing when you need to optimize. And if you can fit it all in a function and it meets your use case and it gets you there faster, great. But then when you want to figure out how to get things as optimized as possible, lowering cost, lowering latency as things start up, breaking things down into one bit of business logic per function is the most appropriate way to go. That gets your package sizes down smaller, which improves startup time.
Yeah, but also don't let it get you into analysis paralysis either, right? You got to strike a balance between all these things to where you're not delivering anything because you're too busy trying to optimize. I think that's the hardest balance to strike, personally. Anyway, Chase, this has been awesome. Thank you for joining us. I mean, you've been on Twitch with me a couple times now. It's always a pleasure, but you brought a cowboy hat this time. I don't know how you're going to top this appearance, man. You've really set the bar really high.
Well, I'm going to top it by saying, may the 4th be with you.
Oh.
Yeah, we didn't have any Star Wars talk or shout-outs or anything, did we? Mo, what's your favorite Star Wars movie?
Oh, man. Of all of the ones I've seen, it has to be The Empire Strikes Back.
And Mo, how many Star Wars movies have you seen?
2.
I had to do that too. I'm sorry, man. I really didn't want to, but I had to.
Man. Hey.
Yeah.
It is what it is. Okay. It is what it is. I'll get there at some point.
Chase, are you more of a Star Wars or a Star Trek person?
Oh, definitely Star Wars. Definitely Star Wars. Yeah. Okay. I just saw a thread on Twitter yesterday where people are raving about how awesome the TIE Fighter game was. And I just have to say that if there's any good in this world, someone will remake TIE Fighter so that we can play it again. Yes.
I had X-Wing versus TIE Fighter. Yeah, that was a real, man, that was one of the, you're right.
Yeah.
Great game. It's a really great game.
I gotta say that when I was deciding on which pop culture things I should catch up on, mind you, because I grew up in an immigrant family, so like it was like, oh, there's a lot of things, references that I'm not getting. It was between all of the Marvel movies, all of the Harry Potter movies, and the Star Wars movies, and the Star Trek, but whole lot of pop culture to catch up on, right?
Oh yeah.
So
yes. They're all good ones.
Star Wars: A New Hope. Star Wars: A New Hope. It took a few tries before I could get through that.
It's a little rough.
Empire Strikes Back was really good, but
I'm going to say something really, really upsetting, and maybe will lose a lot of cred for me in my life and in the community. At this point in my life, I think I like the Harry Potter universe more than I like the Star Wars universe.
Wow.
Oh, that's wow.
I know. I think it's kind of cooler, honestly. I didn't grow up with Harry Potter.
I don't know if you're going to be
older.
allowed on Twitch again. You might have just been banned.
Nobody has ever allowed me on Twitch ever. I don't belong here, but I just keep showing up, and they can't make me go away. And I keep bringing friends too, like Mo. Like Mo's here now too. Yeah, I don't know.
Farrah you, by the way. You got a very big when you said that.
I don't know if that's a positive or a negative from Farrah. You've seen all the Harry Potter movies, right, Mo?
Oh yeah. I mean, I was in elementary school when the books started coming out, so it was easier to catch on to that pop culture. Whereas, yeah, there was a lot of tech debt, essentially, when it came to Star Wars.
I mean, Anna is always going to get my back with Harry Potter. She just did. We're both Ravenclaws. We're both Polish. We're both Texans. We're both old English majors. Anna and I have like these weird, like deep connections, like from I don't know how, but yeah.
I think Anna might need to be your next guest.
I guess, yeah. She's pretty awesome. You hire some really cool people, by the way, Chase.
Oh yeah, we got a great team at Stackery.
Yeah, I have to give a shout out for your team. Your team is really amazing. Danielle, Farrah, Anna, like all these people are incredible. Anna, we are practically twins. I mean, it's weird, like Luke and Leia, maybe, except not with the weird like romantic side, just the familial side. But yeah, I mean, this has been great getting to know Stackery a little bit more, getting to see apparently my favorite language, right?
Apparently, right.
Apparently, yes. My favorite language, C# here represented. What do you want to leave us with, Chase?
Go and build more serverless.
Yeah, I think
that's what I want to leave you with.
That's pretty good.
Serverless
what do you think?
For everyone.
Not going to go wrong.
Hashtag serverless for everyone.
Yes, serverless for everyone.
Yeehaw.
Oh.
Hashtag howdy partner.
Here we go. Farrah's got our ending. She reminded me of our ending. Mo came up with an ending for howdy partner.
Well, I came up with 3, right?
Yeah, and the guest gets to choose.
Yeah, so it's between giddy up, you can say yeehaw, and the last one was
y'all come back now.
Y'all come back now.
Y'all come back now. You hear?
There it is. All right. So join us tomorrow, actually, at 2 p.m. Pacific for another episode of Howdy Partner. And then also Wednesday, it's a Howdy Partner week, but from now on we'll be streaming every what do we have? Every Monday and Wednesday at 2 p.m. Pacific. Anna also seconds the y'all come back now. I think y'all
come back now, you hear?
Yeah, so y'all come back tomorrow. It feels so unauthentic for me to say y'all. I don't know. It just
and he's a Texan.
I know. And yeah. It's weird. But y'all come back tomorrow. And be sure to check out we got a partners panel on Wednesday at 9 a.m. Pacific that Paul wanted me to plug, and give it up for Chase. Thank you, Chase, for coming on. We really appreciate it. One of our wonderful partners from the Partner Network that put on a cowboy hat for us. Not many people would do that. So we'll see you all tomorrow.
And cowboy hat as well. We'll see y'all. We'll see y'all tomorrow.
Y'all come back now. You hear?